It's a nice day out, and you and your friend decide to go to your favorite restaurant. You order your usual meals, but this time your friend decides to get a side order of the restaurant's newly added pot roast. She comments on the nuance of bitterness, but continues to devour the savory meal. About 10 minutes pass, and your friend seems a little off. You both agree on leaving, but in the beginning of the walk home, she drops to the ground, letting out a loud scream and desperate gasps for air. Her body goes into convulsions as she begins to vomit blood, then finally loses all consciousness. An investigation of her death and many others who died soon after eating at this particular restaurant took place. All signs pointed back to the pot roast. All of her sudden symptoms led to the conclusion of poisoning. But what could it be? Hello, my name is Hank Green.
No, I'm Hank Green.
Just kidding.
We wish. I'm Wendy Zane.
And I'm Kayla Taylor.
And this is our chemical reaction crash course.
Dark edition. You're probably wondering what the ending to that heartbreaking story is.
Or how in the world bitter pot roast led to such a horrendous death.
So, let's take it back.
In the 1950s, sodium cyanide was used across the globe for various reasons, but it was most frequently used industrially and in gold mining. When the phrase gold mining is stated, the image that pops into our head is laborers panning for nuggets underneath the hot summer sun, sweating profusely.
Well, that isn't exactly the industrial method used today, thank goodness. Today, most of the world's gold is not found in nugget form, but rather in gold powders and rocks. This means that there is a need for a special type of extraction that can be applied to separate purified gold from all excess materials.
Sodium cyanide, or rather sodium gold cyanide, which is represented by the equation behind us. The gold forms strong bonds with cyanide molecules, and then it becomes soluble in water. Then it reacts with zinc to turn back into a solid, which is then smelted to form into gold bars. This process is not only used for the mining of gold, but also other extractions involving expensive metals.
Sodium cyanide may look like an innocent and helpful inorganic white solid, but today we are very aware that it has extremely deadly properties.
Before we get into how exactly sodium cyanide killed that young girl, let's first talk about how exactly sodium cyanide is made and why it's so fatal.
Here with us today, we have Dr. Nicole Breesy, a New York forensic toxicologist who is an expert on adverse events of chemicals and poisons in the human body.
It's a pleasure to be here to discuss what an intricate poison sodium cyanide is. Did you know sodium cyanide is actually a byproduct of hydrogen cyanide when it is combined with sodium hydroxide? This means that it is man-made through chemicals reacting and is not found in nature.
What?
A chemical reaction is a reactant plus a reactant that yields or produces a product. The actual creation of sodium cyanide is hydrogen cyanide, a reaction, plus sodium hydroxide, another reactant, which then yields sodium cyanide and water, the product.
This is the molecular formula of sodium cyanide. The molecular formula being the formula giving the number of atoms of each of the elements present in one molecule of a specific compound. But if we wanted to turn it into the empirical formula, or the formula given the proportions of the elements present in a compound but not the actual numbers or arrangements of atoms, how would we simplify it?
Due to sodium cyanide's molecular formula, it cannot be simplified any further, therefore it's also making it the empirical formula as well.
Because of sodium cyanide's formula, you can see that the same elements are found on both sides of the equation, but look different because they are in different spaces. This is known as a double displacement reaction, also known as the double replacement reaction or metathesis. Is a type of chemical reaction where two compounds react, and the positive ions, cation, and the negative ions, anions, of the two reactants switch places, forming two new compounds or products. However, don't get that confused with decomposition reaction.
Decomposition as in when something dies and slowly starts to decay?
No, same concept of breaking something down, but this is a decomposition reaction, which is a type of chemical reaction where one single compound breaks into two or more elements or new compounds.
To my research, other types of reactions are synthesis and combustion. Synthesis reaction is a type of chemical reaction in which two or more simple substances combine to form a more complex compound. Then we have a combustion, which is an exothermic reaction in which something reacts with oxygen. Dr. Breesy, is that correct?
Yes, that is right.
But how exactly does hydrogen cyanide even play into this equation?
Hydrogen cyanide is an extremely volatile poisonous liquid. You may be wondering about how people gain all this deadly exposure and how murderers can get their hands on it. Well, it is in our everyday settings, from productions of plastics and extractions of steel all the way to solvents for many salts.
I heard about an incident involving sodium cyanide in China.
Oh yeah, did it have to do with the exposure of the poison to the public?
We sounded a little too happy about that. But yeah, it was a company who had over 700 tons of it, for industrial use, of course. But after the explosion of the company site, the risk of sodium cyanide contaminating the air, water, and people around it was critical.
The spill was very dangerous, especially at these levels, but the nature of cyanides means that they can detect them easily and monitor the process of cleaning up. From what I heard, the cleanup process is as quickly as possible, and now all of the hydrogen cyanide and sodium cyanide are gone and no longer pose a risk.
After hearing a story like this, my one question is, if it is in so many products around us, how are we all not suffering from its effects?
Although there are risks to skin absorption when it comes to sodium cyanide, inhaling or swallowing the poison is what has the biggest and most potentially fatal impact on the body. In small doses, such as 50 to 60 parts of HCN per million parts of air, we don't begin to have these serious consequences until you reach the 100. Therefore, small detection in indoor air, outdoor air, the pits of fruits, and bitter almonds are not enough to cause serious effects.
If it takes so much to actually injure or kill a person, then how did that girl die if she simply consumed her pot roast without any issues?
To start off, the detection of sodium cyanide is very hard as it has seemingly odorless smell. However, that little smell packs a strong punch. Most reports of survivors claim to have recalled a bitter almond smell and residue.
Now everything makes more sense. That is why the young girl had tasted such bitterness in her pot roast. How could a chemical that we produce and use for other things make it into the kitchen and into a pot of food?
Well, sodium cyanide is very energetic in the sense that it can be found in any location. It is never late to the party. In the air, it exists as small droplets, sprays, and very fine particles. This can then transfer to contaminate our water sources through food and agriculture. But in this case, the dish cleaner used a contaminant that contained a good amount of sodium cyanide to shine the pot, this making whatever entered the dish a recipe for death.
So how exactly does NaCN affect our body once it enters? Does it just slowly eat our organs away until we're nothing but a walking corpse? Or does it just make us bleed out until there's no blood left in our body?
Well, not exactly. Once the sodium cyanide is inhaled or digested into our body, it begins to have a very strong reaction with a little protein with a very big job. Cytochrome C oxidase is a membrane protein found in our mitochondria.
Mitochondria?
We know what that is.
Powerhouse of the cell.
That is right. This little protein helps carry the flow of oxygen throughout the body, essentially enabling us to breathe while also breaking down food oxidation. But when sodium cyanide enters the body, it begins to bind to the protein, essentially cutting off its function to be able to carry out oxygen throughout the body, leading to death by suffocation. Hence the reason that that young woman was left gasping for air.
So a simply made meal of pot roast resulted with a tragic end of a young life.
What a sad way to go.
Speaking of going, I think it's time for me to leave. If you guys have any questions, I would love to come back and be featured on your crash courses again.
And thank you for watching this episode of Crash Course Chemistry, Chemical Reactions.
Dark edition.
In this episode, we discussed the decomposition reaction sodium hydroxide plus hydrogen cyanide, which yields the deadly sodium cyanide, and the difference between decomposition, synthesis, and combustion reactions. We briefly mentioned its molecular and empirical formula and the chemical reaction of sodium cyanide in one's body. Lastly, we talked about how to write the equation for sodium cyanide as a decomposition reaction.
That closes us out for this episode of Chemical Reaction Crash Course. We hope you enjoyed this week's episode and can't wait to see you all again next week.
In gold form. If you're watching this right now, we apologize.
I don't look at y'all, I don't laugh.
Okay, you ready?
Are we restarting? Oh, just this part? Okay.
That's so... There's a whole big hole in my shirt.
This reaction is a type of chemical reaction.
What is wrong with you? I'm sorry, I didn't mean to
Oh wait, my spot's gone. Pause it. Let's look the sun.
Subscribe below. Turn it over. Where do I even start? Wait, no, that wasn't.
Yeah.
Press space after she says
Go.
According to my research.
You did research. You just copied my research.
I just added 3 words to your research. The burp. Okay.
The whole thing.
We're so sorry, Nicole.
Oh my god.
No, we're not gonna restart it.
Goodbye.
Bye.